All right, welcome to the 4.3 video. For today, the equation is, or the question is to solve the equation of 3 to the 2x plus 6 power equals 3 to the x minus 1. So you can pause here, also wait just a little bit so that way you can try to answer the question on your own, and then I will go over it. Oops. All right, so when I have a base that is the same on both, which in both cases here, I have this 3, come on both of them. So I'm going to make this equal to the 2x plus 6, that is my exponent in my first, and then x minus 1, which is the exponent in that next one. And then solve for x. Minus 6, and you should get that x equals negative 7. So make sure that you go ahead and put this in the bin. This will be your last grade for the quarter, and then you should be getting out your notes. It's on page 8 at the bottom, and it is 4.3. It'll look like this. So you'll want to go ahead and pull that out. And then we'll get started. If you need to pause the video here so that you can get everything out, that is fine. So the logarithmic parent function is f of x is equal to the log of x. And remember that when there is no base, then the base is 10. So this really would say like log base 10 of x, but we don't write it if it is a 10. So our log of x, our function, if we were to graph it, would look something like this. It's just an example. If you type it into Desmos, log x, and look at the graph, you get a function like this. And if we look at the graph for a exponential function with base 10, then we get a graph like this. So we have to notice, and we're going to talk more about this later, is that the logarithmic function is the inverse of an exponential function. And again, we will talk about that more at the end of the unit. We'll talk about all of the inverses, but I did want to point this out, that the log function is the inverse of an exponential function. So that is all for the graphing. We're not going to go any more into that right now, and we are going to go on to your next page, which is solving some logarithmic equations. So first step when we are solving logarithmic equations is that we need to condense each of the logarithms. And then we are going to use what is called the one-to-one property. And that one-to-one property just means that if I have the log of the same base equal to itself, then I can set both of those parts equal and then solve for any extraneous solutions, which just means that those solutions, for example, just would not exist. And we'll go over those in a moment. So after you use the one-to-one property, then we solve. So in this first one, I have a base of 5 on both, and because it is the same, and I didn't want to highlight everything, I just wanted to highlight. Why is it doing this? Just wanted to highlight that. Okay, so because they are the same, then we can take the inside and just set them equal. Very similar to what we did with exponential functions. So we take 5x plus 9, set it equal to 6x, and then we can solve. And you get 9 equals x. Number 2, again, these are the same. So then I'm going to put the parentheses equal to each other. So I'm going to have 1 minus 4n equals 2n plus 43. And then solve. So I'm going to take that 1 subtract 43, I guess. It doesn't matter. We'll do the 1. That's where I started. Negative 4n equals 2n is 42. Subtract the 2. Divide by negative 6. Which gives us that n equals negative 7. And what you're going to do is you're going to be plugging these in to the equation like every time just to make sure that it works. So let's try the next one. So the next one, for example, 9 is the same. So I have 6 minus 3w equals negative 2w. And then we are going to add that 3w. We would get 6 equals negative 2w, divide by negative 2. And we get negative 3 equals w. I totally did not do that right. Back up. I made a mistake. Negative 2 plus 3 is just w. So that would be my answer. Make sure that you're always plugging it back in. So if I did the log of 9, so this is our check, and I plug in that 6, then I would get the log of base 9 is 6 minus 18, which gives me the log base 9 of negative 12. And we cannot have a negative inside our logarithms. So that means that this is not going to work and we would have no solution. So we can also do these in a very similar fashion to how we were doing them yesterday. And we can just type them in, especially when you start getting lots of pieces. So once you start like adding or subtracting or multiplying things on, that is when we are going to go ahead and use Desmos. So we're going to take all of those pieces, and I thought I had Desmos pulled up already, and I guess I don't. So let me open it up. Desmos. So we're going to go ahead and type in, and remember you can actually just type in LOG, and then in our parentheses we're going to put the x plus 5, so that will go in one line. I always suggest putting y equals in the front. Just get in the habit of doing that, because in some cases it's just a number, and if you just type in a number it won't actually graph it. Plus the log of 4. And the other one we're going to do is what comes after the equals sign, so that would be y equals the log of 72. And we are finding then where these graphs intersect, which happens to be here, and then your x value is your solution. So 13 here would be the solution. So I'm going to type in this in line 1. Make sure you put a y equals in front of it. What comes after goes in line 2. Again, make sure you do y equals with it. And then you're going to find where they intersect. and that was at 13. You use the x value, and when you plug it into Desmos, make sure that you are using x as your variable. Otherwise, it will not always work right. So make sure you switch that to x. And then you're going to do the same thing for the rest of these. You're just going to take them, type them in, and then find your solution. So we are going to go ahead, and I will let you go ahead and solve those. And I'll put the answers on so that you can make sure that you are getting the same thing. So again, you're just typing them into Desmos and solving. So for number 5, you should get 18. For number 6, you should get 2. For number 7, you should get 9 over 2, or that would be 9, 4.5. And that would be your W. 7 for number 8. And then you should get 2 solutions for this one. And I'm going to go ahead and solve this one out for number 9. So if you want to pause the video and do 5, 6, 7, and 8, you can. Or if you don't need more time, then we can keep going from there. Okay, so we have the same value here. Sorry, my phone's ringing and I'm not picking it up. So when we have that squared, since we have the same base value, then I can go ahead and set what's in the parentheses equal to each other. And then we can move everything to one side. So I'm going to subtract the 18 and add the 7m. And then we're going to factor it. So my factors of 18 that add to be 7 are 9 and 2. And these should be m's. Minus 2. And then set them both equal to 0. Oops, minus 2 equals 0. Solve for m. And make sure you always check, plug them back in to make sure that they work. They both do work in either scenario. So you have 2 answers here. Number 10, since we have this plus sign, go ahead and put it in Desmos. And you will again get 2 answers. You will know you have 2 answers if you have something to the second power inside your parentheses. So you should get k is both positive and negative 4. When you are equal to just a value, such as what we have here, then again, just like we were doing, you're going to go ahead and just type it into Desmos. So whatever's in front of that equal sign, that's line 1. And then whatever comes after the equal sign, that's line 2. And I'm going to put the answers here so that you can go ahead and check to make sure that you are getting the right thing. So you should get the x equals 72. And then for the next one, you are going to get 18.25. Then you should get 10 and 20 and 3 and 5. And that's where we are going to stop for today. There is a Desmos, there is a Delta Math exit ticket that is posted to Canvas, so you're going to want to make sure that you do that. And then in your homework, you can do questions 1 through question number 40. Yep, question 1 through question 40, I think, is what it looks like. Yeah, question 1 through 40. That looks good. Okay, so you have both of those things to work on, and then you will be set for the day.